right, so level one of evaluating one variable expressions, 1.1.1 section. So first off, an expression is when we have, um, a, well, for our purposes, they'll always have a variable, and we're going to have a value for the variable that we can plug in. And then to evaluate means that we are trying to get a single number answer in the end. Okay, so in this example, we have that b is equal to 2. So b is our variable, and we are going to replace it with the number 2. So here is the expression they give us. 9b is the expression. Okay, so we would rewrite the expression 9b, but instead of putting b now, in parentheses, when we substitute a number in place of a variable, it's almost always a great idea to put parentheses there. So I think for the most part we can always do it. So then put the 2 there. Now sometimes it can be confusing. What are we actually doing here? Because there's no symbol, but whenever there's parentheses next to a number like this implies multiplication, right? You could, if you want to, you could rewrite this as 9 times 2. That's what it means. But anyway, in this case, that would just be 18. Right? 9 times 2 is 18. That part, if you want to use a calculator to check yourself, that's totally fine. And that is for smart scorers. That's the type of expression you'll see to solve, to evaluate from 0 to 18. Now for level 2, smart scores of 19 to 59, it's very similar to level 1, I would say. This time, notice that we have an addition expression, right? 5 plus x. This time, our variable is equal to 11. Okay. So again, we're going to rewrite the expression 5 plus x. 5 plus x, except instead of x, we're putting 11 in there. Okay, in place of that. So now we can calculate it. In this case, we don't really need the parentheses, and there's no question that, hopefully there's no question about what operation we're doing because we see the plus sign. So this is, if you want to get rid of the parentheses, that's fine. You could write it as 5 plus 11, and 5 plus 11 is equal to 16. So in this case, 16 would be my final answer that I would submit. Getting into level 3, it gets a little more complicated. Now notice that our variable is equal to a negative number, okay, negative 2. That's okay. So 4d to the second power. So that really means 4 times, and d is, remember, a variable, so it represents a number. In this case, we do know that the number is negative 2. So 4 times a number squared. All right, so the way I would set that up is 4 parentheses squared. Now we happen to know that that number is negative 2. So I can plug negative 2 inside the parentheses. Okay, now there is an order of operations thing going on here because we have two things going on. We have multiplication here for 4 times, and then we also have an exponent. So with the order of operations, we always do the exponent before multiplication. If you remember the acronym PEMDAS, meaning you would always do parentheses first, inside parentheses. There are parentheses here, but there's just a single number in the parentheses, negative 2. So negative 2 all by itself, there's nothing to do there. So we would then move on to the exponent, e. Right? So that's second. Third in this order of operations is multiplying or dividing there at the same level. They're on level 3, step 3. So we will do that after. And this problem doesn't have it, but if it did, the last level, the last thing you do is add and subtract. So anyway, yep, we're going to do, this is going to take 2 steps. So first, the exponent. So, and remember, an exponent of 2 means multiply that number by itself twice. The 4 would stay, and this means -2 times another -2. That's what the exponent of 2 means. So then that's 4 times -2 times -2. If you remember, a negative times a negative is a positive, and 2 times 2 is 4. And then we have just one more multiplication, 4 times 4, which is 16. So the final answer that you would submit for this problem would be 16. Okay. Level 4 will get you to a SMART score of 80, the required SMART score. You can see it gets a little more complicated. One main thing to note is, notice that we have 2 variables. It's the same variable, but we see the variable k show up twice in this expression. And that's okay. We'll just plug 2 in for each of them. All right. Now this one will definitely have to be careful with the order of operations. So let's carefully write this out. So 8 parentheses 2, exponent of 2 minus 36 parentheses. Now remember, this means that 36 is being multiplied since there's no symbol there. So if you'd like, you could put a little dot there to show that it's multiplication. Minus, and then some unknown number. But of course, in this case, we do know the number, which in this case, it's 2. So I'm going to put 2's in both of those spots where k was. All right, so again, order of operations, PEMDAS. So first, we're looking at inside the parentheses. So I see inside these sets of parentheses, we have 3 minus 2. Okay, so that's what we'll do first. 3 minus 2 is 1. So, you can do more than one step at a time here. So actually, I think I will also do exponents, because the exponent here does not impact the parentheses, the stuff I showed in red. So we can actually do both of those at once. That'll be fine. So we'll still have 8. We're not doing anything with 8, but remember, 2 to the second power, 2 to this exponent here, if I show it off to the side here, that means 2 times 2. So that's 4. I'll keep it in parentheses to show that it's multiplication. That means 8 times 4 minus 36 times 3 minus 2 is 1. Again, so remember these are actually 2 multiplications. That's 8 times 4. This is 36 times 1. We also have a subtraction there, but our next move, we're at level 3 of PEMDAS. We're going to multiply or divide, and I see 2 multiplications. So we'll multiply each of those separately. So 8 times 4, that is equal to 32. Minus is still there. 36 times 1 is just 36. And now we only have one more step, and that lines up with PEMDAS here. It's subtraction. Be careful here, because you will get a negative number since you're subtracting a bigger number than what's there. So what I think of is, okay, if I was going to subtract 36 minus 32, I know the answer would be 4. But since we're going backwards, it's going to be negative, and the answer will actually be -4. That's how I think of it. Yeah, there you go. So that's what you would submit for this problem, is -4. All right, so level 5 will be optional since it brings you to SMART scores above 80. But I'd like to show it to you in case anyone's ambitious for this. So now some different things here. Again, we have the variable shows up twice. So we're going to have to plug in this, we're going to have to substitute this number in twice. And look at what the number is they want us to substitute. It is no longer an integer. integers are numbers, 0, 1, 2, 3, and going on forever that way. But also they could be negative, right? I think we had a negative number before, but so they could also go forever in that direction. So these are the integers. So if it's got a decimal point or a fraction, those are like a new type of numbers, right? If you remember, I believe we talked about this before, but this is a rational number. Okay, but anyway, so I would probably utilize a calculator when I'm doing this one myself, but let's at least get the setup. The setup is the exact same, so it'd still be -2 parentheses where the f is, exponent of 2, plus parenthesis 2. Now we have to put another set of parentheses where the f would be, and another set of parentheses to put the f inside of it, and then the exponent of 2. So it's very, notice I'm being very particular on how I'm entering in, how I'm writing all that out, okay, with the parentheses. Okay, and then now it's -2.6 inside each set of parentheses, -2.6. Almost didn't leave myself enough space. All right, and again, we're working with PEMDAS. So we're working from the innermost thing first, inside parentheses. And I see inside the parentheses, inside the inner parentheses, there's just a single number on each of them, so nothing to be done. But there's another set of parentheses here, and we can multiply inside there. Okay. And at the same time, I will apply this exponent on this side. Okay, so it'll be -2. Okay, so now -2.6 to the second power. I'm going to type that in here. You can type -2.6 to the second power. I know that means -2.6 times another -2.6, which is +6.76. Okay, so that's 6.76. Again, and that makes sense that it's positive because it's a negative times a negative. Okay, good. Now, one thing to keep in mind, notice if I type, so if you do Shift-6, that means the exponent. And if I put a 2 here, see my answer is -6.76. So parentheses really makes a difference, because if I write it this way, the exponent is only on the 2.6 and not on the negative sign. So that's kind of a tricky thing there. So you could, if you wanted to write it with the exponent, you could type with parentheses. So now notice that it is now a +6.76. So there you go. Anyway, continuing on, now we have plus, and now 2 times -2.6, that is going to be -5.2 when we multiply those. And it still has the exponent of 2, right? That's still got to come down here. Okay, so now the next level is we can do the exponent over here, and we'll have to multiply on this side. All right, so again, I'm going to utilize a calculator. So just a little search bar there. So -2, and if I just type it just like you see, parentheses 6.76, and then equals, that's -13.52. So nice little calculator built into Google here. Of course, you can use a different calculator as well. And now -5.2. And we could type it just like you see with parentheses, -5.2 to the second power. And that's 27.04. And then, of course, adding those, I know the answer is going to be positive because the negative number is smaller. So when you're adding a negative plus a positive, the sign will be whichever number is larger. So in this case, it will be a positive answer. Yeah, I'm fine if you want to use a calculator here, but it's good to just have a good idea. Oh, look at that. It's 13.52. Positive, though. So it's positive. Here, I'll write it this way. Positive 13.52 would be what you would submit. And that is evaluating expressions in one variable.